Okay, here's the E-8 video. So derivatives of trig functions. So we already have, so basically guys, we've got two ways of organizing these derivatives in order to remember them. Okay, so this is for the derivatives of sine and cosine. Right, we've already talked about how this works. But then we're also going to have derivatives of secant, tangent, cosecant, and cotangent. All right, and the way that this goes, okay, so the derivative of secant, or the derivative of secant is secant tangent, right? And guys, I'm not putting the x, so really this should be secant of x. Really this should be secant of x, tangent of x, but this is just how we remember them, so I'm not going to write the x in. So the derivative of secant is secant tangent. And guys, look here. If you just write this down, you would kind of see like the secant is next to the tangent. So maybe that'll help you remember that secant tangent goes here. And then the derivative of tangent is secant squared. And then the derivative of the co-ones, of cosecant and cotangent, it's very similar to this. They're just going to be negatives. So the derivative of cosecant is negative cosecant cotangent. And then the derivative of cotangent is negative cosecant squared. All right, so there are the derivatives of those. So in the practice, guys, there's going to be a ton. So there's 48 problems. I'm only asking you to do the odds, so cut that in half. What is that? 24. But that is what it takes to get fluency with these. You just got to do them over and over and over. Remember, I've said several times by now that we're just practicing these skills in order to be able to tackle way more complicated problems down the line. And when we encounter these complicated problems down the line, if you don't know how to do these simple things and you don't know how to do them fast, then the more complicated stuff is just not going to come together for you. And that's what it takes, guys, is a lot of practice to get this down. So examples from the practice. So we're going to find the derivatives of these. So the derivative of 7 tangent of x, the 7 is a coefficient, so I just bring it down. And then the derivative of tangent of x is secant squared of x. Okay, it's right up there. The derivative of tangent is secant squared. All right, each of these spots correspond to its derivative over there. All right, so there's that first one. So that's just a matter of knowing the derivative formula. Now this next one. So y equals cosecant of 8x. Guys, if you have more than just a plain old x inside of a trig function, that means that you need to use chain rule. All right, so in, out. All right, so 8x cosecant of blank. Now you don't, I have said this to a few of you, do you need to use this in and out chart? No, you don't need to use it. You don't need to show it. But if you're making a lot of mistakes, then definitely use it until you stop making those mistakes and you can reliably do the problems without using the chart. Okay, so the derivative of 8x is just 8. The derivative of cosecant of blank, I look up here, the derivative of cosecant is negative cosecant cotangent. So this is going to be 8 times negative cosecant of blank cotangent of blank. And then what goes back in the blank, this time blanks, what used to be in there. So 8x is going back in both of those. Yeah, I definitely wanted to do an example like that because first you have one blank and then you have two, but it's the same inside that's going back in them. So this is negative 8 cosecant of 8x cotangent of 8x. All right, just 2 more examples. Now this one, y equals tangent of negative x. Remember, if there's anything more than just a plain old x, then you need to use chain rule. So the derivative of the inside, the inside is negative x, the outside is tangent of blank. The derivative of negative x is -1. The derivative of tangent is secant squared of blank. And then what goes back in? What used to be in there. So y prime is negative secant squared negative x. Okay, here's the last one. So y equals 2 times cotangent squared of x. Now we've practiced this before, guys. If you've got a trig function raised to a power, the very first thing you want to do is put that power outside of parentheses and then that trig function inside. So now, guys, you can see that the cotangent is actually inside of another function. It's inside of 2 blank to the second. So this is a chain rule situation. So the inside is cotangent, the outside is 2 blank to the second. The derivative of cotangent, it's on the front, but it's negative cosecant squared of x. And then the derivative of 2 blank to the second is 4 blank to the first. And then what goes back in there is cotangent. So y prime -4 cosecant squared of x cotangent of x. Okay, guys, I hope that was nice and clear. The practice should go fast. And I'll talk to you later. Bye-bye.